All right, IB Physics. So we're going to go over a couple of these problems because I know that you would find that helpful. I'm not going to go over one of these, at least in writing, where we have our free body diagram drawn and we're just finding the net force in each direction. Because I think you'll find it pretty straightforward. So 3 up, 3 down equals 0 in the y direction. And then I would say, oh, there's a net force to the left of 5 newtons here for problem B. But let's take a little moment to go over maybe this last problem. I know some people really had some difficulty with this last problem because it has a lot of information in it. And so when I'm doing a physics problem, really any physics problem, I take a little moment and make sense of what it's telling me. So it says we've got this cart, mass 40 kilograms, it's being pulled with a force of 24 newtons, and it can accelerate at 3 meters per second squared. And the problem is asking, what is the net force on the cart? So just kind of drawing a little setup, I've got this like cart, this is a picture, and it's being pulled this way, probably along some sort of floor, and I want to know the net force. And so I'm going to write down what I know in the problem and draw my free body diagram. So I know the mass is 4 kilograms. I know that the force pull is 24 newtons, and the cart accelerates, so it's the acceleration, at 3 meters per second squared. And I want to know what the net force is. That's our question. Okay, so I bet you could probably just answer this without drawing your free body diagram, but I'm just going to draw our free body diagram to make sure we really understand what's happening. So here's my object. Again, it can be a box or a dot. Either way is fine. I know that the object will have some gravitational force on it, that the floor will then be providing a reactionary normal force on it, holding it up. And we also know that it's having a pull to one direction or the other. It doesn't tell us, so I'm just going with the direction that I drew in this little picture. But also, since it's being dragged along the surface, there'll be some friction force opposing it. And we know the magnitude of this force. We don't know the magnitudes of this force. We could find force gravity and force normal if we wanted to, but we don't have to for this problem. So what we do want to find, what the problem is asking us to find, is what is the net force on the cart. And we happen to know that the net force is equal to the mass times the acceleration. That's our handy dandy relationship we found. It is Newton's second law. So I can go ahead and say, oh hey, I know the mass in the problem is 4 kilograms. I know the acceleration is 3 meters per second squared. And so I can find the net force, F net, is then 12 newtons. And in fact, now we're done with the problem. That's all they asked us to do. Based on this information, though, you could tell me some more stuff about the forces on our object. Since we know the force pull is 24 newtons, you could then tell me what this frictional force is, because the net force, F net, in our problem here is equal to that pull force minus that friction force, because it's in the opposite direction. And so since I know the force pull is 24 newtons, I can actually find that frictional force by, so 24 newtons minus force friction equals the net force of 12 newtons. Okay, I bet you can tell me what the frictional force is. So this problem has more information than we need in it, and that means actually we can find out some other things about it if we feel like it, but you don't have to. So this is a mild level problem. So let's go on and try the first medium level problem. And so this first medium level problem, I'm gonna start setting up for us. And just like the other one, I go through and I first read I take a moment and say, okay, it says a 60 kilogram student accelerates along a smooth, flat hallway at 0.5 meters per second squared. What is the net force acting on her? Okay, find the force of friction. Amount of force being used to push the student. Okay. So we have some information here, and just like before, I'm going to take a quick moment and jot down what that information is and my knowns. So my knowns include a 60 kilogram mass. We also know that the acceleration is 0.5 meters per second squared. And then we're looking for the net force. And just like before, part A, I bet you can find right away. Probably you don't even need the free body diagram, but I am going to draw my free body diagram to make it a little bit easier to think about what's happening in the problem. So the student is being pushed along the hallway. We can maybe think of this as like the student is in a wheelie chair or something. And so that means that there's going to be a gravitational force downwards, just like usual. Always have that force gravity downwards. That force will be balanced out in the y direction by the normal force from the floor. I'll even add my nice congruence marks in here because I know those two are going to have to add up to 0. The student's not going to fall through the floor. Then they're being pushed down the hallway. So I'm just going to call this force push to be as descriptive as possible. And we read in one of the later parts, part B, that there is a force of friction. Sometimes problems might say that friction is negligible. Negligible is a word that means it is not relevant. It's so small that you can ignore it. But here, clearly we have some friction. So I have my free body diagram set up. Notice the problem didn't give us a direction, so I just picked a direction. It's to the left. No, it's to the, you can see the way of the arrow push. It's to the right. Yeah, right and left are hard. So we can go ahead and take this and say, great, we know what's happening in terms of the forces. I've drawn my free body diagram. You're always going to want to start with a free body diagram on these problems. And now I can go ahead and start addressing some calculations. So part A asks us to find the net force, F net equals question mark. That's what I'm looking for. And I'm going to go ahead and write down my equation. F net is equal to m a, again, Newton's second law, super handy. And we can go ahead and calculate that. It will be 60 kilograms times that acceleration of 0.5 meters per second squared. And we get a net force of 60 times 0.5 is 30 newtons. Yay! Go team. So now I actually know the net force. And something we learned is equal to 30 newtons. So I'm adding that into my list of knowns. Then I'm going to move forward to part B. So part B says, find the force of friction if the coefficient of friction, ooh, that's another thing we know, is 0.11. So the coefficient of friction is 0.11. Coefficient of friction is just telling us how frictiony the surface is. We learned a little bit about this last quarter. But if you don't remember, that's okay. We have the force of friction. We can actually calculate using the coefficient of friction and multiplying that by the normal force. Force normal. Okay, so to be able to do this, we need to say, well, I know this, but do I know the normal force? So I'm going to go back to my free body diagram and see what I know about the forces in the x direction and the forces in the y direction. And I'm actually going to focus right now on the y direction. I know that we have a force normal up, force gravity down, and that those forces are going to add to 0. I'm going to add in these guys as well, just for sake. And this added up to 30 newtons. So this is my sum of the forces table, and what it's telling me is that in the x direction we have a net force, which means we have an acceleration, but in the y direction there is no net force because we're not going to sink into the floor or fly off the surface of the floor. So that means that the normal force will actually be equal to the gravitational force, And if you don't remember that force gravity equation that we learned last quarter, Fg equals mg, definitely write that down somewhere because it's pretty useful. And this little g is the acceleration due to gravity here on the surface of the Earth. It's 9.81 meters per second squared. Sometimes we round it to 10 to make calculations easier. And I'll go ahead and say, oh, great, that means mg is the normal force, and I can go ahead and plug that in right here. So force friction is going to be equal to this coefficient of friction times the normal force, which is the mass, times the acceleration due to gravity in this case. It's not always exactly what the normal force is equal to, but conveniently today it is. And so I can go ahead and say, well, I know actually all of these quantities. The coefficient of friction is 0.11. It's unitless, doesn't have any units. The mass we already know is 60 kilograms. And the acceleration due to gravity, like I said, is 9.81 meters per second squared. And here's where I don't have a calculator on. Oh, I do. I have my cell phone. I'll do a quick calculation. So I'm going to take 0.11 times 60 times 9.81, and I get 64. That seems very reasonable. So I get that the force of friction is 64.746, but 0.7 newtons. Yay! Go team. Okay, so now I know the force friction. We did part B. That's another thing that I can write down on my knowns. Force friction equals 64.7 newtons. So then we can move forward to part C, where we can go ahead and say, what is the amount of force being used to push? So that's force push equals question mark. That's what we're looking for. And so to do that, I'm going to go ahead and look at my x direction. And I'll say, oh, well, since I know that the net force is actually equal to the force push minus force friction, I can go ahead and solve for force push. Force push will equal F net plus force friction. I'm just adding friction over to the other side of the equation. Equals F push. And now I've run out of space. Oh no. So let's write in really small. So then I go ahead and say, oh, I know the net force is 30 newtons plus the force friction is 64.7 newtons. And so that means that the force push is 94.7 newtons. And again, boxing my answer, and we did it. So as we're going through these problems, you want to make sure to start with your free body diagram and writing down your knowns from the problem. If the problem is a little bit puzzling, it can be really helpful to set up a picture. This first one, just pushing a thing, we've done that before, we've seen that before, so we know what the free body diagram can look like. But if you're unsure, setting up a picture really helps. Then we go through and solve problems finding our net force, using our sum of the forces table to really break down what information we know in both the x direction and the y direction, and using these handy equations, force friction equals the coefficient of friction times the normal force, force gravity equals mass times the acceleration due to gravity, to help us move forward through the problem. So hopefully you found this helpful, and hopefully I'm not over my recording time yet. Oh, 30 seconds to go. Winner.